Welcome everyone to the Our Connected Universe track, aka everything about APIs. We're so stoked that I can glimpse at so many people's faces through the light, and we're really looking forward to all of the talks in the track today. Now we're running a little bit behind schedule after the opening address, so we're going to kick right into our first talk of the day. And we have up first Anushka Vidanage, and Jess Moore, and they're going to be presenting building health software on decentralised health data using personal online data stores. I'm really excited for this talk. Take it away.
Thanks, Jack. Right. Good morning, everyone. So, first I would like to begin today by acknowledging the traditional custodians of the land on which we meet today, and would like to pay my respect to their elders past, present and emerging. And we would also like to acknowledge our Indigenous partners on this project that we are doing at ANU, who these are from Yarrabah, North Queensland, the traditional owners, Gurriny people, and the historic owners of that land. I'm Anushka Vidanage, and here with me is Jess Moore, and we are from the Software Innovation Institute School of Computing from the Australian National University. And today we'll be talking about personal online data stores and how do we build health software using personal online data stores. And this is a brief outline of our talk. So I'm gonna do whys and whats of these something called pods, personal online data stores, and solid pods. And I'm gonna dive a little bit deep into some technologies behind these solid pods. And then Jess will talk about our actual project where we build this health software using solid pods. Okay, so not sure if everyone can see that. So what I did was I asked ChatGPT what are the problems with centralized databases, and here's what I got. So there's a long list, but I want you to focus on these three aspects. So basically these three aspects highlights the aspect of data privacy and security, and lack of transparency, and the lack of data ownership. So the privacy, as evident by latest data breaches all over the world, here in Australia as well, for instance, Medicare and Optus, as some of you may know. So the centralized databases are prone to security and privacy risks, always. So one of the reasons being that they can be these centralized databases because they hold a lot of data about let's say hundreds of thousands of or even millions of people. They can be attractive to many adversaries out there. So a successful breach to these centralized databases could reveal sensitive information about yourself. So and obviously there's a threat of privacy where our own data is most of the time handled by someone else, some central authority. Right, and then the lack of transparency. Centralized databases often rely on central authorities or administrators, what we call them, and we basically put our data on their hands and we basically trust them because sometimes that could be our only option, right? And in return, we do not really get to know what happens with our data and what kind of raw data really they capture about ourselves and what do they do with them. So even though the privacy policies such as GDPR enforce the practice of transparency, there will still be gaps with these centralized databases. You might remember the incidents with Cambridge Analytica scandal. So yeah, so there's lack of transparency and finally the lack of ownership. So when relying on these third parties to handle our own private data, we don't really get the ownership of our own data, right? What we get most of the time with these systems is some kind of a statement or a document stating that they gather this kind of data of ourselves and this is what they are doing. We don't actually get to see the raw data itself. Yeah, so, and that comes with the lack of interoperability with centralized databases. We are dependent on one database for a one service, where we cannot really migrate between databases if we want to. So these are some of the main issues with centralized databases. So can we somehow solve these issues or address these issues? Can we somehow turn this around? And that's where the concept of pods, personal online data stores, comes into play. So a personal online data store is a place where you can store your own personal data and also have complete control over that data. So the concept of pods is framed around the individual. So the individual is at the center. As you can see here in this picture, and then individual can access their own data in their own pod. They can see what's being stored. They are the one who store this data, and then individuals are better informed about their data. And the service providers, they come at around the individual here. So they provide different services based on the data that's been stored inside our personal online data store. So that's the basic concept of the personal online data stores. So it's just not only a data store as well. So it's an ecosystem where programmers, developers like you and me can quickly build stuff, programs, softwares, applications, and get our innovative ideas out in the field. So we can build software to use the data on pods as a third-party application. So that's the basic idea. Right, so what is solid pods? So solid is basically, it's a short for social linked data. It's a web decentralization project led by Tim Berners-Lee. It's initially released in 2016, and it contains a specification that lets individuals store their data securely in a centralized databases, these pods. So it's a place where you can have your own data stored in your own pod and start doing stuff with those data. So start giving access to others on your data, things like that. So following solid specifications, multiple servers has been built. So multiple open source solid servers are available out there. So the most popular one is the community solid server, which is here in the first link, and then you have PHP solid server, or you also have solid server as a plugin for Nextcloud. So the difference with all these servers, the concept of these solid servers is that for the solid specification compared to centralized options is that the centralized options is always get a separate backend, right, for separate services. So you have a separate backend for separate services. For instance, Facebook has their own backend, Twitter has their own backend. But with these solid pods, what happens is that you will have a single backend, which is your own pod, and the apps and the services will be asking for your permission to use your own data, and in return, give the service to you. Right. So I'm going to give a brief introduction to technology behind solid pods, and then hand over to Jess to talk about our actual project. So the technology behind solid pods is mostly based on semantic web technologies. So for each pod, we do have something called a web ID, which is essentially an URI, which is unique to each pod. So each pod can be uniquely identified using this web ID. So for instance, here you can see this is so the first link here, that's my web ID from my pod in wrap.com. So that's a free service which you can go there and build your own pod and start storing your data. So that's the web ID for my pod. And the pods, so the data in pods are saved as something called linked data. Linked data is basically a collection of terms or their definitions and their links, the relationships between them. So for instance, here you can see the link graph. So that's a linked graph where you can see relationships between Bob and Alice and to some of these terms here. So these linked graphs, once we have this linked graph, we can store this in our pods using something called turtle serialization. So what happens is in turtle serialization, what we do is we convert this linked graph into something called triplets, where in triplets we do have these subjects, predicates, and object. So this linked graph is now converted into these triplets, like the ones you see there, and then that's being stored in turtle files. And those turtle files are inside your pods, and that's your data. So that's the basic idea of storing data in solid pods. And then, so the authentication stuff and the authorization stuff. So in solid pods, they use something called OpenID Connect. It's an open authentication protocol that works on top of OAuth 2.0 framework. So for instance, if you log into Spotify using Facebook, you can log into Stack Overflow using Google. So that's Open ID Connect or 2.0. So that's the authentication protocol that's running behind these solid pods for authentication purposes. And for sharing the data, it's using something called web access control ontologies. So you can see in pods, how do we share how do we give access to others to our own data? That's being done using access control lists. So that's this web access control ontology. So you can see in this picture, so you have given access to these two people, P and that's line 1, 2, 3, 4, 5. So you have given access to the file medical.ttl to those people, and what specific access has been given, that's given in the last line. So you have given control, read, and write access to those two people for that medical.ttl file. And that's how you usually give. So you can give either one of these three controls to someone else. So for transparency, you can also have logs where you can record this access sharing as well. So you can have a look at later stage. And built-in pipeline. So when migrating, so this is kind of, now we are going into our project here. So when migrating from existing systems, or coming from existing systems to these decentralized databases, these decentralized pods-based systems, one of the challenges we face is that we cannot really fully migrate at once into these pods-based concepts, right? So it should be a step-by-step process, a gradual process, and that at some points pods-based systems need to coexist with the current centralized systems. So we need to build pipelines from and potentially to these systems, from these pods-based to existing systems, using these pod-based systems as well. So what happens here is we employ, in our project, what we do is we employ Python to build these pipelines. So it's a simple process. What we do is we extract data from existing systems, and then we pre-process data. So in the pre-processing, what we do is we sometimes do some data aggregation, maybe do some data encryption, data masking, things on top of the extracted data. And then what we do is we transform data into these turtle formats, so RDF formats, and then we feed that data back into solid servers. And this can again be done vice versa as well if needed. So we can extract the data from solid servers, do the exact same thing, and feed that data into existing systems. All right, so in our project, so far we have developed, so we are mainly working on something called Flutter and Dart for developing our applications. That's in the front end. In the back end side, we are using mainly Python, for instance, building pipelines from these existing systems. So Flutter is a cross-platform app development technology, so the underlying language is been Dart. So in this project, we have so far developed 3 open source packages to use with our applications. So the packages are being Solid Auth, Solid Encrypt, and RDF-lib. So Solid Auth package, as the name suggests, you can do authentication from and to pods. So you can do, whenever you build a Flutter, Flutter application, you can use this Solid authentication package to do the authentication into any pod out there, right? And in the Solid Encrypt, then you can use this package to encrypt your data inside your pods at rest, encrypt and decrypt data. And the RDF-lib package, that's a Dart package for working with RDF. And this package could simply extract triplets from the existing turtle files in our pods and create these RDF graphs. And also, once we process these graphs, we can export it to a turtle file as well using this package. So that's a quick introduction to 3 of the packages that's been developed under our project. Okay. Yes, that's where I hand over to Jess. Thanks.
Thanks, Anushka. So now I want to talk about this project that we're doing with the Yarrabah Indigenous community. So their health service, Gurriny Yealamucka Health Service, they reached out to us. They were looking to basically have better data infrastructure in their IT system so that they could support personalised strength-based care, recognising that in their community, where they've got a really high disease burden with diabetes, rheumatic heart disease, and a number of other challenges, it's really important to keep people, to bring the care to the patients, and as much as possible, keep people being treated in community, so they have their connection to their country, to their people, which gives them their source of strength. And that, so they're looking to this to have a better system that will help them to be able to both support patients through having better communication with their doctor around their integrated health, and for the doctors to be able to monitor the patients that they're treating in this way. So using Solid, each patient and their doctor has their own pod. And we're building the health software where patients can access and control how the data is shared from their pod. So we've built 3 pods-based applications. The first is what we call the Indie app. This is the app for patients, which allows them to access their health information, the advice from their doctor, such as their prescriptions, and to be able to share their integrated health data back to their doctors. So they're in control of the sharing. Then there's the Health Worker app, because we realised that the care coordination teams that were going out to patients in the community, they were actually using paper and pen to do much of their recording, and then having the load of bringing that back to the clinic and having to put it back into their patient information management system. So this allows them to have the patient data with them on the fly throughout the community, be able to update that and have it sync back to their system. And then the third app is the Gurriny app, and this is the one that's going to provide the analytics to show how patients who are being treated in this way are performing in the community. So we have set up Yarrabah Solid Server, where each patient has their pod, and they're each individually encrypted, and those pods can be hosted on any solid server. In the Indie app, the patients have their granular control over what data they share or decide not to share. And that also means that they can delegate control, perhaps to a trusted other person. And those access control lists that you saw there, they control access to each of the RDF resources in their pod. They can view the access that they have given and change access to stop sharing to a particular recipient. Yep. Or they can store additional data and share that to another person. So we're beginning a trial of this pods-based app system with the patients, working with a group of low-risk diabetes patients that are being recruited to the trial, and these will have the opportunity to engage with the medical staff and with us around the design and development of these applications for them. So there'll be a number of yarning sessions where we're developing the data governance framework that the different leaders across the community want to have for the patients, working with representatives. And then that'll be implemented in the consent model within the pods. And then working with those patients who are able to come to those sessions to better improve how we can give them access and make it transparent, the consent that they are able to control. And at the end of the trial, we envisaged that there would actually be multiple community groups that would have pods-based applications. And then this would allow patients who are attending different activities, you know, whether it's Men's Shed, the arts community, or the footy club, to then have their attendance in those activities immediately ingested within their pod. And this is the kind of information that the doctors believe is really important to the cultural and integrated health of their patients. So using pods, we're able to provide that infrastructure for distributed or individually governed data, which can be just within communities, or it can be extended outside of communities to other entities that have pods to be able to receive data using solid technology. And each person can then be in control of the data that they share and confident that it is encrypted and safe within those solid servers. So this raises a number of challenges. We briefly mentioned, you know, the challenge of setting up the pipelines and migration to those existing systems. Because moving into a pods-based architecture of data, the data is effectively stored like a knowledge graph. And so there's that transposition from a relational database or other type of database into the graph RDF format. But once it is in that format, standardized RDF formats, then any other external pods-based application could, through the access control lists, request access and basically offer that software to be able to connect with a person's data in their pod. Then there's also the aspect of data security. So while the data is relatively safe because it is only decrypted on device, that still does open the potential for backdoors on those devices. And we're in this future environment where privacy has become much more important, people becoming much more aware of privacy. We have legislation changing throughout the world around privacy, you know, being led very much by the GDPR in Europe. However, implementing those rights is really, really challenging. So one of those is the right to be forgotten. With pods-based data storage, you can turn off access. So perhaps I've been giving my birth date as a piece of information to government agencies, and then I say, no, I no longer want to do that. I've lost faith in them. But then you don't know whether or not it is deleted. So there is, at the moment, still dependent on this aspect of trust even though we do want to move to a trust no one environment. So, and finally, consent models for data sharing need to be simple to understand and use, as well as being feasible to build. Consent is not consent if the individual does not understand what they have consented, or they're not able to review or change that consent. So working with the Indigenous communities that have a very strong understanding of data governance, we're able to benefit from that strength of history that they have there, and their understanding around, for instance, that access to data is to be earned. And we can design and build the consent model that supports the communities to have the kind of access and control over their data that they are seeking. So with that, I just want to say thank you. Thank you to you all for coming to hear about building with pods, and also to our team. So this work, wouldn't be possible without the trust of the Gurriny Yealamucka Health Service up in Yarrabah, and without our wonderful team led by Professor Graham Williams in the School of Computing at ANU. Some of our researchers, Sergio Rodrigo Mendez, and our software engineers, Ninad Bhatt and Zayon Shu, and Ninad's with us here today.
Thank you. Masks and earrings. And mics and earrings, apparently. Does anyone have any questions? And you're going to have to make yourself clear because I can't see much.
Is there any expiry-based ACL structure? So you might want something where you don't want somebody to, like, instead of having to revoke it, is there a way to have it that you can set the expiry on it?
Right now, we only have revoking access in the solid pods technology, but we can build on top of that to have expiry-based ACLs.
Two up here, and then we might pull.
Where am I going?
Migrating to like a semantic web-based technology is the learning challenge. Are there communities that you participate with to like kind of start building up that knowledge skills that are going to be required to get to semantic web-based technologies in Australia?
Yeah, okay.
So we got quite a lot of speciality around semantic technologies in the School of Computing. And through their involvement and their connections to those communities is really how we're connected there. But certainly we are seeing this movement to setting up communities, working with Solid, which a large part of that is recognise that needing to drive the development of standards in how we structure and store data in RDF and triple format.
I'm sorry to cut off the other people, but you probably noticed we're a little bit behind. So we'll defer hallway questions. Go find Anushka or Jess out in the hall. And we want to say thank you very much to both of you. And Ridwan has a little gift for you as well before you bail on the room. We'll see you all back here at 11 for our next talk.